Hello and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing illustrative math, grade 8, unit 8, lesson 9, practice problems. Okay, our first question here says, which of the triangles are definitely right triangles? Explain how you know. Note the triangles are not drawn to scale. So, how do we prove a triangle is a right triangle? Well, if it satisfies the Pythagorean theorem, then it must be a right triangle. So for A, we have 9 squared plus 12 squared equals 14 squared. 9 squared is 81. 12 squared is 144, and 14 squared is 196. Does 81 plus 144 equal 196? Quick check. 4 plus 1 is 5, not 6. That does not work. So A is not a right triangle. Now let's check B. Square root of 50 squared plus the square root of 50 squared equals 10 squared. Square root of 50 squared, those are inverse operations, cancel out. 50 plus 50 equals 10 squared is 100. 50 plus 50 equals 100. That works. So B is a right triangle. Now let's check C. (16 squared plus 30 squared equals 35 squared. 16 squared is 256. 30 squared is 900. 35 squared is 1225. Does 256 plus 900 equal 1225? No, it does not. C is not a right triangle. Okay, next we have D. That's our hypotenuse. 10 squared plus 10.5 squared equals 14.5 squared. 10 squared is 100. 10.5 squared is 10.25, and 14.5 squared is 210.25. Well, 100 plus 110.25 does equal 210.25, so that is a right triangle. Now, triangle E. Square root of 3 squared plus the square root of 13 squared equals 4 squared. Square root of 3 squared is 3. Square root of 13 squared is 13. 4 squared is 16. 3 plus 13. That works. E is a right triangle. So B, D, and E are the right triangles out of those. A right triangle has a hypotenuse of 15 centimeters. What are possible lengths for the legs? So those have to be A and B. And we know that a squared plus b squared has to equal c squared. So whatever a and b are, they have to equal 15 squared, which is 225. What will equal 225? Well, 10 squared is 100. So a could be 10, then what would b be? That would be 100 plus what is 225? Well, 100 plus 125 is 225. So we could have 10 and the square root of 125, whatever that works out to be. Or is there a nicer value we could use? Well, if a were 12, 12 squared is 144. (144) plus 81, which is 9 squared. So nice values, a equals 12 and b equals 9. Those are nice values that would give us a hypotenuse of 15. In each part, A and B represent the length of a leg of a right triangle, and C represents the length of its hypotenuse. Find the missing length given the other two lengths. So A squared plus B squared equals C squared, so 12 squared plus 5 squared equals C squared. 12 squared is 144. 5 squared is 25. Equals C squared. 144 plus 25 is 169 equals C squared. To isolate the C, we have to take the square root, do it to one side, do it to the other. Those will cancel out. C is equal to the square root of 169. Does that come out nicely? Ooh, it does. 13. Now, our next one, A, we don't know. So A squared plus B is 21 equals C squared, which is 29 squared. A squared, we still don't know. 21 squared is 441. Equals 29 squared, which is 841. Before we can finish isolating the A, we have to get it alone on one side of the equal sign, so we have to get rid of this 441. Do it to one side, do it to the other. A squared equals 841, subtract 441, which is 400. To isolate the A, take the square root, do it to one side, have to do it to the other. A is equal to the square root of 400. Does that come out nicely? Ooh, yes it does. A is 20. Okay, what's next? For each triangle, does the Pythagorean theorem express the relationship between the lengths and its three sides? Well, the Pythagorean theorem only applies to a right triangle, and only one of these is a right triangle, so it applies to B. Andre makes a trip to Mexico. He exchanges some dollars for pesos at a rate of 20 pesos per dollar. While in Mexico, he spends 900 pesos. When he returns, he exchanges his pesos for dollars, still at 20 pesos per dollar. He gets back 1/10 of the amount he started with. Find how many dollars Andre exchanged for pesos and explain your reasoning. If you get stuck, try writing an equation representing Andre's trip using a variable for the number of dollars he exchanged. So, how much money did he exchange? I don't know. What do I use to represent a number? I don't know. X. He exchanges it for pesos at 20 pesos per dollar. So if this is how many dollars he had, that will be how many pesos he had. Then he spends 900 pesos. Or 9,000 pesos. When he returns, he exchanges his pesos for dollars, still at 20 pesos per dollar. So this is how much money he had when he got back, because that's what we started with. We exchanged it. We spent 9,000. When we change it back, it's at 20 pesos per dollar again, but now we're dividing by 20. And how much money did he have at the end? Well, how much money he had at the end was 1/10 of what he started with. 1/10 of his starting value. So now we just have to solve for x. Anything we can do in those parentheses? No. But 20 over x is, if we're subtracting, let's just give each of those a common denominator here. Let's just leave those separated. 20 over 20, those will cancel. So x subtract 9,000 over 20. What is 9,000 over 20? Ooh, that's 450. Equals 1/10 x. Okay, now we have x's on both sides of this equation right now. So let's get them all on the same side. Well, the left side here only has numbers and the right side doesn't. So let's leave the numbers over here and get all the x's onto the right. How do we get rid of an x? Well, we subtract it. Those will cancel. Negative 450 equals 1/10 x subtract x is 9/10 x. Now, how do we isolate the x? Divide by 9/10. Just to make it easier to put in a calculator, I'll write 9/10 as 0.9. Do it to one side, do it to the other. Those will cancel. Ooh. Nobody caught that and pointed it out? You're probably yelling at your screen. 1/10 subtract 1 is negative 9/10, which means I need to divide by negative 9/10. Now, negative divided by a negative is going to be a positive, so I'm not going to bother punching those negatives into the calculator. 450 divided by 0.9 is 500. So, if 500 is x, we wrote an equation using a variable for the number of dollars he exchanged, how much money he started with. He started with $500. Okay, this has been another episode of Boskin Does Some Math. Thank you for tuning in. See you next time.